Okay. So today we're going to go ahead and talk about file and directory manipulation in Unix. So I know that technically this is the Python focus group, but there's going to be quite a lot of build up to get to the point of us running files because there's so much kind of background that goes into this. And I wanted to briefly note that when I first started learning how to code and using bioinformatics, I didn't know of all the tools that were available to me. I didn't really know of all the background things that I needed in order to even be able to navigate the terminal and how to troubleshoot some errors that were outside of just Python alone. So the reason that I'm kind of focusing right now on navigating the terminal and dealing with all that stuff is because that's going to be immensely helpful down the line. I think it's almost as important as learning how to write an actual script. So we're going to learn how to mess around with that. So last time we went ahead and made a GitHub repository called Python Focus Group. So if you can go to that Python Focus Group directory. So for me, that was in Mount C users wiki documents GitHub. And then I see my GitHub repositories here, and I should have my Python focus group. So this is wherever you stored it. If you put it in documents, if you put it in or on your desktop. So if everyone, once they've navigated there, you should see your, um, let's see, you should see your session from last time. So it should say like session one. Can I get a thumbs up or some indication from people that they are able to navigate back to their folder from last time? I'm seeing some thumbs up. So as we can see here, everything is organized by session. Remember last time I was saying we had a session 01 instead of session 1, and I said generally I recommend naming it with a 0. Well, what if you had accidentally done session 1? So you just made this directory, session 1, and you're like, well, this doesn't actually match the way that I set everything else up. I want to rename this. So there's actually a command that's called move. So we made our directory, but we can use this move command. And this move command is actually quite powerful. It can be used to actually move files, move directories, and also rename things. So similar to how at the terminal, if I wanted to change something, or let's go to GitHub and Python focus group. So if I wanted to rename this, I could easily do something like this. But we can't really do that at the command line. So we need to use an actual command. So what we're going to do is type mv, which stands for move, so the M and the V in move, and then you put your source, so the session one. Let me see really quick if I can shift my screen over so you can see it better. There we go. So we can move session one and then change it to whatever we want to change it to. So this is saying change this first thing into whatever I give it. And these are both command line arguments. So the first argument is the source. It's what you're moving or renaming, and the second is what you're changing it to. So let's say I just want to capitalize it, or in this case, since I already have a session 1, I want to put session 001. So now if I do ls, I see that that session 1 is gone and it's been replaced by this session 001. So now if we were to go and say, actually, I want it to be session 2 instead of 1, since now we're in session 2, which I imagine you would like to do, we do the same thing. We say mv, and then we say our source. So now we want to rename session 001, and we want to name it session 2. So session 02. I already have one, so I'm just going to put a 0 here so I can mess around with you guys. So now if we do another ls, which is listing the contents of the directory, we should see that there is a session 002 instead of a session 001. So this is how we're going to make our folders, and if we make a mistake typing, that's okay. We just go ahead and rename it using move. So now let's say we go into session 002. I'm going to pause briefly and make sure that everyone has been able to make the session directory and also been able to rename something as an example. I get a brief thumbs up or reaction, make sure nobody's fallen behind. I see a question in chat.
Hi.
Victoria, you.
Sorry, yeah, I put it in move MV session dash sorry underscore one and then whatever that thing is and then session underscore 001 and then it said source target source directory, but when I did the list it didn't show. It still showed session underscore one.
Did you make the directory? You have to make it first because the source needs to exist when you go into it. So maybe
I did.
you did?
Yeah, because I made the session one as you were doing it, and I was trying to like do the move thing as you were doing, but it didn't go through, I guess.
Okay. Let me see. I also could not rename. I get usage MV source directory, source target. Interesting. So that's seeming to be a common issue and also kind of a bad issue because you should be able to move things. Um, when you're going ahead and moving it, I'm in my session two, so let me just make that session one directory again. So if I want to move that, are you tab completing? So like, are you hitting the tab button and then completing? So like start typing session and then hit tab and let it complete itself? Because it might just be, is it not completing itself when you hit tab?
I think the only difference between my line and yours, it looks like there's no space in between the tab and the session 001. But when I tried that, it said um when it said no such file or directory.
If you're okay with it, do you mind sharing your screen and we can take a look? Okay, can you type ls, please? So you have session 01, session 02, session 1, and now you want to rename it to session something else? You're muted, Victoria.
I'm sorry. I now it worked. I didn't know why, like, because when I did this, I think so. Does the space
Yes.
is it? Oh, okay.
Yeah, so
Sorry.
it needs to be. No, I mean, this is why we learn this. Like, we learn this because stuff like this is what we smooth out over time. So, yeah, you have your source and your space and then a target. So, this might actually be a good thing to go back to what we talked about last week, how having spaces when you're doing stuff in bioinformatics has a tendency to mess stuff up. So if you have a file name with spaces, you have to tell it that that's a space and not a separate argument. And this is a really good example because this space at the command line is telling the command that this and this are two separate things. So when you're renaming, if I just do something like, let me see where I'm at. Okay, so I have session one. So if I say move session one, and then I have a space, and then say three, now I've essentially just made it three. But if I say moves three and I don't give it a space and just say something like two, it's not going to know what's happening. So if you do run, usually if you're using the command line and you're not using the command correctly, there's almost always a help flag in some capacity. So you can say, I don't really know what's going on, so let me look at mv dash dash help. So it tells you that the usage includes MV, any of the options, which here are the command line options. Those are all things that down the line you can choose to add in, and we'll learn about that later. But then there's also the source and destination. So the source and the directory that you want to move. So it says rename source to destination or move sources to directory. So that's the command's information. And see how it says mandatory arguments. So these, that source and these target are arguments. So it's saying that this command is expecting two different arguments. It's expecting a source and it's expecting a destination. And that needs to be separated at the command line with a space. So I realize I stopped sharing my screen. This is the help. Hopefully you were able to follow along by running MV help. But yeah, this shows the different usage and the different arguments at the command line. So yeah, that space usually means to your command line there's two separate things, not the same thing, so that actually does matter. So I see there's some other people that were having trouble renaming. Did that fix it? Are you still struggling? I don't see any comments.
Yeah, I still get the negative F, negative I. Um, I don't know why. It does say I have a session one, like, but you guys can move on without me. I can figure it out.
Okay,
I don't want to take too much time.
okay. We'll go ahead and move on. Ymir, if that doesn't resolve, then maybe we can revisit it a little bit later. Julian, I will resend the link. There we go. So yeah, this is the process of renaming a file. So now we should be in session 2. Let me clear my screen. So once inside your session 2 directory, remember in order to change into the directory, you need to run cd and then whatever directory you're changing into. So now that we're here, let's say we actually want to create a Python script. So there should be this command we learned last time, touch, which creates a file. And we're going to create this file called first Python script. So touch first underscore Python underscore script dot py. And now if we run ls, we should see that there is a file here. So one of the things that we'll start to learn when we're coding is that the things that you write should be informative in some capacity. They should explain what you're actually doing. So first Python script doesn't really tell us anything. So for example, if we look at some stuff I was working on yesterday for UNIX single cell, I have count guide RNAs, integrate guide RNAs, UMAP. Like these are all explanations of stuff that I'm doing in the script. So if I want to go back one day and say, I've written a script that does this thing before, where is it? Something like first Python script is not really informative. So we're going to actually rename it to do something that is informative. And it's actually kind of a custom that the first thing you ever run when you're learning to code something is hello world. So for now, we're going to call it hello world. So we're going to say move first Python script. And remember that if you already have that file, you can just hit the tab button, and it will complete it for you. And now we can rename it, so space, and then rename it whatever we want. So we can say hello world.py. And now if we do ls, we should see hello world.py. So now one of the things we're going to go into is kind of related to organization. So as you're working on your workflows and your data analysis, you're probably going to have inputs and outputs and genomes and different directories that you're working in. And one of the essential skills is going to be organization of your stuff. So if you created a subdirectory, so let's say we create a directory, make the directory called scripts, and inside we see hello world and we see this directory scripts. Like, well, I actually want to move my hello world directory into the scripts directory. So we'll say move hello world into scripts. So previously, remember that if we did a source and destination, it would actually rename it. But this command looks for the destination, and if this destination exists, it's going to put it in that destination. So if I say move hello world.py to scripts and I say ls, now hello world.py is gone. But if I list the contents of scripts, we see now that it's inside the scripts directory. So this is how you start moving things at the command line. So this is really important for things down the line, like having raw data where you're trying to organize your data. This is important. I think we're going to actually talk about some aliasing in a moment, but this is going to be really important for any sort of project organization. So we can also, let's try something. So let's say we say a scripts directory. Let's make another directory called Scratch. And this is going to be a directory that contains scripts that we're working on, stuff that's kind of in the works, code we don't want to get rid of yet, but stuff that eventually we might want to loop in. So now you should have two directories, something like Scratch and scripts. So if we go into Scratch, this is also a good example. So remember when I say tab complete, if I do sc, it already, like when I hit tab, it completes to scr, but that's because the scr is shared by both of these. So I need to give it the first unique letter of the directory before it's willing to tab complete. So I have to say cd a, and then it will tab complete. So now we have a script here. Let's pretend we're going to do something related to organization. So touch rename files.py. So we're creating a file called renamesfile.py, and that should be in our Scratch directory. For now, we're just going to focus on command line stuff. I think next session we'll start getting into the actual Python stuff. So don't worry about putting anything in the file yet. But now if we go back a directory, remember cd dot dot means to go back a directory. We should have two things, Scratch and scripts. So if I do, let's say now I've worked on the stuff in Scratch. I've fully finished my rename files.py. It's no longer Scratch, it's usable code. I want to move rename files.py from Scratch into scripts. So this is where it starts to get a little more confusing. Before, we're just moving to target to destination within the same directory, but here we're seeing how do we move stuff within this directory to in another directory. And this is where the idea of absolute or relative paths starts becoming important. So what I can do is use an absolute path. So I can go into Scratch and say pwd, and this is print working directory. So I can give it this whole thing. I can say move this path and then rename files.py, and then we give it the source. But this is kind of clunky. Like this works, but it's generally not the best practice, especially in bioinformatics, to use absolute paths. Because if I wanted to share this code with you, how would I do that if you don't have an MNT, users, Wiki, documents, GitHub, Python focus group session 2? Like you can't really do that. So it's common practice generally to use absolute paths when you're doing, or relative paths when you're using things. And a relative path is just something that's relative to where you're at. So if I am in session 2, what I can do is say I want to move the thing in Scratch, which is our rename files.py. So I've given it a path. I said you need to go into this directory and find this file, and then you need to move it into the scripts directory. So now if we look, so ls, and we'll touch on this in a moment, this is a wildcard. But if we do ls and then the wildcard, it'll show us Scratch has nothing in it anymore, and scripts has both scripts in it. So you need, one of the most important things I noticed when I had taught the Python workshop in June last year was that a lot of people didn't really understand that the paths really made a difference. So I just really want to stress that where you are at all times matters. This is why it's helpful to know commands like pwd, where you can constantly check where you're at. This is also why you should be checking where you are regularly. When you're moving stuff, you should be using the paths instead of shortcuts. So there's When I say shortcuts, I mean things like MV star and then whatever. But this, all of these things are kind of good practice to build up to over time. So even though it might seem slow right now and we're just moving a file back and forth between directories, this is going to be increasingly helpful later when you start to organize data and scripts for a project. So the next thing I want to touch on is instead of moving files is something like copying files. So let me clear my screen really quick. So I have my Scratch and I have my scripts. Let's say that I actually tried running the thing in scripts and it's not the output that I needed. Oh, let me see. There's Nat, you're asking what console I'm using. Do you have Windows or do you have a Mac? Windows. Ah, are you getting the error where it says that the commands are not found when you try to run anything? Because that's probably what's going on. I see you typing. Okay. That's fine. For now, just follow along. I will send you this link really quick. And this is going to have instructions on setting up the terminal, and there should also be a recording from the last session that you can catch up on. So for now, just kind of pay attention to the commands and then go back and try some of the stuff on your own. Okay, so yeah, let's move to copying files. So like I was saying, it's really common that all of the commands we use have some sort of shortened notation. So copy is just CP, copy. So as I was saying, let's say that we had run this thing in our scripts and it didn't do what we wanted. We thought it was complete. It's not. We want to add functionality. We want to change something. That's fine. So instead of moving scripts back to Scratch, we could actually make a copy of it. So we can say CP, which is copy, and then we'll tell scripts and say rename.py, and we'll copy it into Scratch. So notice that this uses the very same notation. It uses this move source destination. This is really common when you're doing anything involving like moving, aliasing, deleting, or not deleting, deleting you just give it. But this is very common where the first thing you're talking about is the source and the second thing is the destination. So here we're saying copy this file into this destination. And so now if we look at our directories, we see that Scratch has rename files.py and scripts also has rename files.py. So this might be helpful if you're trying to make those changes as I mentioned, but I'd like to highlight that GitHub is what we set up last time, and that keeps a version history of everything, which is good. We want to keep version history so that we don't have to do stuff like this. Because let's say I start editing this, these have the same name, I don't remember which directory I'm in, and now I have two different files floating around with the same name but different contents, and that becomes really, really confusing. So this is generally not good practice. We'll revisit how to delete this later. But what we can do is instead of copying is we can alias. Or no, I got ahead of myself. We can just remove it. So let's go to the Scratch directory. And what we can do is run this command rm. So rm is remove. So we can remove the rename files.py. And I have something set up at my terminal that asks me if I want to remove something because I don't trust myself fully sometimes. I've deleted too many things accidentally. But for you, it might just have gone through and that's it. But for me, I make it ask me before it deletes something and I have to tell it, yes, I do want you to delete that, and then it will delete it. So if I say ls, before we saw that rename files was there and now it's empty. So let's say now in Scratch, I make a ton of files. So let's say touch 1.txt, touch 2.txt, touch 3.txt. Let's say I have these text files. So I have 1, 2, and 3.txt. Now let's say I want to remove them. These are all text files. I've separated data somehow, and I have all these files, but I don't actually need them separated. Or I tried to generate something and it's just not the output that I wanted, so I need to delete it. So what I can do is use something called a wildcard. So there's this symbol, this star symbol, that means it represents any character and any length of characters at the command line. So if I go to back to session 2, for example, and say ls, it just shows what's in the current directory. If I say ls star, it shows me everything in the current directories. So I say ls star, and it actually breaks down Scratch and scripts. So similarly, if I go back to Scratch, if I say ls, I should see 1.txt, 2.txt, 3.txt. If I wanted to remove these files, so using that rm command we just learned, how would I delete these? Let's say that this is 40 files. You do not want to sit there and manually rm every single one of those 40 files. So if there's a pattern in what you're doing, for example, all of these are text files, I can say rm star.txt. And this is saying remove anything that ends with .txt. So again, it's going to ask me, yes, I would like to delete it. But now if we do ls, all of our outputs are gone, or all of our text files are gone. So this is very powerful. It's really helpful when you're navigating or trying to do things in mass. So like if I wanted to go to a directory and look at all my outputs and all subdirectories, I can say something like ls star and it will go through everything really quickly and nicely. But it's also very dangerous because doing something like remove and then a star, if you give it a pattern accidentally that matches something you didn't want to delete, it's now gone. And that is precisely why I have that failsafe for myself here. Ah, this Y, like I have to click Y in order to delete something. So be careful when you're using it, but it is helpful, especially for pattern matching. So let's say in Scratch, let's recreate some files. So let's say touch 1.txt again. We'll recreate 2.txt, 3.txt. Oh, see, I typed a little too fast and now I have to rename that. So now I say move 3.xt to 3.txt to correct that mistake. I got a question. Removing files is permanent, correct? No going back. Within reason, yes. There's a lot of kind of workarounds to this. So, for example, on Hive, you can pay to have a backup of your data, and it's backed up in certain intervals. But generally speaking, unless you restore it from a backup, like and you maintain the backup, your deletion is pretty permanent. So if I say RM, that thing's disappearing forever. And admittedly, I have, again, this is why I have the failsafe for myself. I've done something where I accidentally deleted the entire copy of my index genome, and that's a 6-hour job to run. So I had to sit there for another 6 hours and redo the whole thing because I accidentally deleted it. So there's still, that's why I say, like, just be careful. It's important to know what you're doing at the command line for that reason. Okay. And that's actually a really good segue into this section here, this rm-rf. So remember earlier I was saying that if you wanted to see how something works, you can write dash dash help. So rm dash dash help, and this will show all of the options. So here we see there's a dash f, which is force. So the first thing that I showed was that I had to tell every single one of these text files to delete, and I had to say yes. But let's say I don't want to do that. So what I can do is say rm-f, and this means force it, and then star.txt. And this didn't ask me this time. It force deleted everything. So I'm going to clear this again. So that force deletes anything. It does not ask, it never prompts, it ignores everything. It will just delete as you tell it to delete, which makes it very powerful and very scary. But I also wanted to highlight, let's make a subdirectory. So we're in Scratch. Let's make a subdirectory called let's just say data for now. So if we do ls, we should have a subdirectory data. Now we want to remove this because we want to reorganize or it's empty or whatever the case. So we say rm data, and it yells at us. It says, rm cannot remove data, it's a directory. I don't know what you're doing. So in order to delete a directory, we have to do something called recursion, which means it it is recursively going into this directory, deleting everything inside it, and then stepping back and deleting itself. So in order to specify that, there's this dash R here. So we can say dash R as our option, and this removes directories. So we can say rm dash R data. And then see, it's asking me because I didn't give it an F, so I say yes. Remove it, and it removes the directory. So again, this is really helpful because you don't want to have a bunch of empty directories floating around. You don't want to have a bunch of unorganized stuff. So you need to be able to remove, rename, reorganize as needed. The only downside is that you're probably going to make mistakes. Like you will, it sucks, but that's why it's important to kind of be aware of what you're doing and also how to fix those mistakes, including the fact that if you remove something, this is powerful and you won't get it back. So use it cautiously. So, on that note, we have an ability to actually link things. So, let's go back a directory to our session 2. Let me clear my screen. So, we have a Scratch and a scripts directory. So, let's say that we downloaded some data from Novagene. So, we can say make directory. There's actually a command argument dash p that makes all parent directories, which means it's going to create exactly the directory structure I give it. Novagene usually downloads data like Novagene 01 raw data, something like this. So let's now do an ls, and we should see we have Novagene, Scratch, scripts. We can go inside Novagene, and then we can tab again because there's a raw data file. And we'll say ls. And there's nothing here because we didn't actually download data, but we're going to make some fake data really quick. We're just going to make empty files to work with. So I'm going to try something really quick and see if that fixes this. No? Okay. My path is getting increasingly long, so I was hoping I could fix that for you guys, but I cannot do that very easily. Okay. So while we're here inside this Novagene directory, we're going to make some example FASTQ files. So we're going to use touch sample1.fq.gz, touch sample2.fq.gz. So these are just gzipped FASTQ files. In this case, we did not put anything in them, so they're just blank files. But now we want to go back to our session 2 directory. So we have our raw data downloaded, Novagene. Let's go back to session 2. And remember I said going back a directory is just 2 dots. So if you want to go back twice, you can do dot dot slash dot dot and it'll take you back 2 directories. So it'll take us back 1 and then 2 to session 2. So one of the things, and this is going to be really helpful when you're working on Hive and working with actual data, data takes space. There's a lot of FASTQ files that are in the several gigabytes large range, if not larger. I've had data that I've had to download that has literally been like a terabyte for the download. If I'm trying to work with that data, I do not want a copy of it because we're paying for storage. I'm sure your computer does not have unlimited storage, so we want to be really mindful of storage. So one thing we can do, and this is simultaneously helpful for storage reasons, but also for safety reasons, is we can alias and create a link to the data. So I can say link. So now if I go ls, I can go into Scratch and I can make a link. So linking is ln, so link. Dash S means it's a soft link. A soft link versus hard link is a little bit different. Soft link means it's just a shortcut. You can't actually like the files are connected behind the scenes, but it's all one file. A hard link is essentially creating two copies of the file in different locations that you can edit, and it impacts both of them. It's a little complicated, but we're never going to work on hard links. Like literally to date, I've never used anything but a soft link. So ln-s for a soft or symbolic link. And similarly, we have source and destination. So the source, we're going to link our FASTQ files. So we're going to go, since we're in Scratch, we need to navigate back a directory. So dot dot, and then Novagene, o1.raw data. And then this is where our wildcard becomes handy. Let's say we actually had like 100 samples. We don't want to have to deal with linking 100. We can use that star, that wildcard symbol, and say link anything that ends with fq.gz. So this is our source, and we need to give it a destination. So we actually navigated to our destination in Scratch. So we're just going to say dot, and that means our current directory. So now if we look in ls, we see sample1.fq.gz and sample2.fq.gz. And this little at symbol, you might not have it because I have configured my terminal to tell me more information about the stuff I'm working with. But for me, this little at symbol tells me that this is actually a link. So if I do ls-al, which you should be able to do as well, it should show you actually where that is linking to. So it's telling me that sample1.fq.gz is actually linking to Novagene 01 raw data sample1.fq.gz. So again, this is really helpful because let's say I'm working on Amber's data and Amber has downloaded a copy of the data on Hive, but I want to do my own stuff, but I don't want to impact the data that she's working with or accidentally delete it. It's safe to create a symbolic link because let's say I remove sample one accidentally. It asks remove symbolic link. So I can say yes, I can remove the symbolic link. But if I go back to Novagene and look at it, the original data is still there. So this gives us an ability to work with the data, kind of copy it into a location convenient to us without actually copying it and not really having the ability to change or delete it very easily. So I think this is something very powerful. And as you start getting used to working with more data, I really recommend that you use symbolic links to work with raw data. So the other thing we can do as a failsafe is just change the permissions of the data. So we can make it so that the data can only be read but not deleted. Um, I see my file didn't get deleted in the Novagene directory, but it didn't ask me if remove symbolic link. Is this something? Yeah, so Victoria, that's a setting that I have. I can show you. So this is my bash RC, which is like my computer configuration stuff. So I have this thing called alias rm that aliases to rm-i, and dash I means interactive. So that means I'm basically telling my terminal every time I run rm, actually run rm-i, so that it will ask me if I want to delete something. Similarly, like I was saying earlier that I have the ls-f. Like when I do an ls, I have information about if it's a file, if it's a directory. That's because I actually told it every time I run ls, do ls-f. Similarly, remember earlier I said, let me try something, and I saidghub, and I just runghub and it takes me to this directory. It's because I have told my terminal every time I typeghub, change the directory into my GitHub directory. So there's a lot of things that you can do kind of behind the scenes that will make your life easier. But this is why we're learning the basics. It's like you build up to the point of being like, okay, now I know what I'm doing. I've made my mistakes. Let me figure out how to make my life easier or prevent myself from making more mistakes. Okay. So yeah, the next thing we're going to focus on is file permissions, and this is going to be really, really helpful because I think this has been a big source of issues for a lot of us in the lab and just in general is file permissions. So if I do, and this is something I would like you all to do, ls-al, you should see everything appear like this. So there's this weird stuff over here. There's a one, your name, possibly your name or your computer's name, and some other information, and then file stuff. So, like, this looks kind of weird. Functionally, the only thing that we typically look at is what's in the directory, but this stuff here tells us the permissions that the file has. This is called a permission string. So each part of this permission string is divided up into different segments. So here is the data type, that first section. So there's a dash, which indicates a regular file. So let's say I go to scripts again. Here we see that there's a dash for hello world.py. That's because this is a regular file. So the first character is telling us if it's a directory. If it's L, it's a symbolic link, or if it's a dash, it's a file. So this is actually holding a lot of information despite being a single character. So the next set, so see how this is RWX, RWX, RWX. This is actually three sets of permissions for three different people. So the first RWX, we'll skip ahead really quick. R stands for read permissions. So R means you can read files, and for directories, you can list and see what is inside a directory. This W, which is writing, means that you can modify or delete a file. So you might have been on Hive or something before and tried to delete, move, or access something, and it says permission denied. That's because the permission string has coded something saying that you as a person cannot access it for one reason or another. That's what we're going to try to address today. But yeah, W is for files, you can modify or delete it, and for directories, you can add, remove, or rename. The one thing that's kind of weird is execute. So executing for a file means you can run the stuff in the file. So it's an executable file. Remember I said that I make my stuff a little more apparent to me when I look at it. So this star to me indicates that it's an executable file, but you might not have the star on your thing, and that's totally fine. But X means that you can run the script if it's a program. But the thing that often is confusing is execute is needed if you want to access a directory. So if you want to enter a directory, you need execute permissions for the directory, which is a little weird. So I will admit I don't remember all of the codes and all of the organization for this stuff. So sometimes when I'm trying to set proper permissions for something, I just look up what the permissions are that I need. It's like once you have the chart and you understand how this is set up, you know what you need. But there's all sorts of different ways that you can go about it, whether you're the group, the owner, the public, and it gets a little complicated. So, as I said, that first section here is the type of file, whether it's a symbolic link, a file, or directory. This section here, actually, I'm going to switch to Hive really quick. I think that will be a little more useful for showing some of the permission stuff. You do not need to navigate to Hive. This is just for demonstration. Okay. Okay. So see, if I'm in ThinkLab, these are my different directories that I have. I see that for some reason, this right part is missing. This means that all of these are directories. This second set of RWX is owner permissions. So this here is the owner. Julian, you own the directory above this. Interesting. But this is the owner. So I own all my own directories in this part here. And then the group, this next part, so the RW, in this case S, RWS, the RWS portion, this is group permissions, and the group is laid out in this part. So here it's showing that I had actually been working on the biostate data when I was still in LaSalle lab, and I had been using their space. So when I move the folder, it says that she still technically owns it. But you can see that now all my newer stuff is owned by Katie Fink Group. So anybody who is on Hive who belongs to Katie Fink Group has the permissions specified in this second set of RWX. So RWS basically is you have all the permissions that I do, as if you own the directory. Now the second is, or the third set is the other. So the last set of three, read, write, execute, the fact that the W is missing means that there's no write permissions. So the public, so anybody who's not part of Kyle Fink's group, can read the files and navigate the directory, but they can't change anything inside here. So they can't come in and like delete my scripts or write anything in it. So these permissions become really helpful when you're sharing data. I think there was an instance where Amber was trying to share data with Julian and he couldn't access the data, and that was because he needed the set of permissions specified for the group. So Amber had permissions because she was the owner, but Julian did not because he is the group and his permissions was more limited. So we can see that there's different permissions depending on what's being run. So Julian has some screen file here that doesn't have any execute permissions. Amber, may I go into your data? All right. So see here, this is a pretty standard permission. It means that anybody who is in Kyle Fink's group can use the stuff in here, but they can't change any of the stuff in here. So this is a pretty safe bet for any sort of shared data or shared group space. But you can also be mean and say, I want to take away all group permissions if I want to and only access my stuff myself. Somebody has done that, and I wouldn't recommend that because it's really hard to get back to everyone having access if you leave. So generally, it's good to have group permissions that are pretty permissive if you're working in a shared space. So we went through the read, write, execute. Now, what if I want to change something? So let's say I go back to my folder. This is pretty solid, but what if I want to change it so that nobody has access to the biostate data but me? How do I change that? So there's actually a position system that we can use. So we can either say we can subtract permissions, we can add permissions. There's different ways we can do it, but the command underlying it is all chmod. I forget what it stands for. I think it's change mode, if I'm not mistaken. I don't remember, but chmod is the command for changing any permissions. So I'm going to quickly clear my screen. So yeah, let's say I wanted to change the biostate data to be only accessible by me. So I can say, all right, let's look at this guide here. 0 means that I give it no permissions. 1 is execute only. W is write, or 2 is write only. 7 is read, write, execute. So I want basically no permissions for anyone but me. So I'm going to say chmod. I'm going to give myself full permissions because the first part is me. And then put a 00 for no permissions for anyone else. So I'm going to say 700. This is a directory, so I have to do -r. And that's actually a pretty massive directory, so maybe I'm going to give it a smaller directory. We'll do this one, which is also apparently quite large. But what we should see is that the permissions will change upon running this. So now if I do ls-al, it has taken away literally all permissions to this single cell except for me. So I have permission to look at it, write it, execute, do whatever I want with it, but nobody else can access this. So if somebody now were to go onto their terminal and try to go into this, they should get a permission denied. So generally, you want everything to be on the strict side as opposed to permissive. I'm a little bit guilty of doing this. I tend to run, if I don't know what's going on, chmod-r777, which means read, write, and execute for everyone. So remember, this is the first thing is owner, group, and then public. So generally for public, a better practice would be maybe read only, or read and execute since it's a directory. So like 775. And I can say, give those permissions to that directory. So this means that if you're the public, you can't write the file. So this is the permissions that was set before, where The first position is read write execute, which is a 7. The second is read write execute, which is a 7, and then the third is read and execute only, which is a 5. So that's where that 775 is coming from. Um, I see two questions. One of them is session 2 chmod 700-r scripts. It says no such file or directory. Interesting. For your scripts, are you in the parent directory? Like if you type ls, do you see scripts?
Yes, I do see that. See that I'm in session 2 right now.
You're in session 2 right now. Can you put a dash capital R and yeah, a dash capital R? I think it needs to be capital for chmod.
Oh, it still says the same thing. So chmod space 700 space dash capital R dash scripts.
Can
Do
you
I need to give it like a full directory?
You shouldn't have to if scripts is already accessible. Can you maybe share your screen again and we'll take a quick look at it?
Yeah. Um, like here.
Okay, can you do a quick ls again? Can you do ls-al? That's interesting because it did change the permissions properly for your directory. So see how it says rwx as it says D, which is directory, rwx, which is read write execute, and then just dashes?
Mm,
That means that you have read write execute permissions, which is consistent with the 7, and then nobody else
mm,
has any permissions, which is the 00 in what you ran.
mm.
So it changed the permissions, but I don't know why it says there's no such file or directory.
But was it so sorry if I do let's say 705
Hmm.
and then do this and then does it didn't change, right?
It did change. So the
Oh, uh-huh.
so look at the permission string for scripts. See how the last three are R and X?
Oh,
That's because the 5 is read and execute permissions, and you gave that
mm-hmm,
to the group. So 705 means you gave those permissions. So my guess is just that the dash
mm,
R needs to go in front for you. So maybe do chmod dash R and then a code. So try like 775
right.
and then scripts. There we go. Yeah, so just put the
Oh,
dash
okay,
R in front.
okay.
So now
Thank
you've
you.
made this. Yeah, there you go. And then Claudia, you asked, so now this directory can only be accessed from your computer. If I do like the 700, then yes. So this is a really kind of confusing concept, I'd say, because there's like so many layers to this. And that's why I was saying like I almost always have to reference it when I'm trying to change permissions properly. So if you're worried about it, just know the main thing you need to know is this is the file type, owner, group, and public. And anytime you need to know what the permissions you want to change are, you can always look up the digits. You can always look up the digits and change to what you need it to be. So here I did 775, which is read, write, and execute for owner, group, and then only read and execute permissions for public. So that means if I send something to the Hive administrators, they can't change anything in here, but they can look at it, for example. So yeah, this is the permissions code. It's pretty important to know, but again, just emphasizing you always have the reference. You can always look it up. And this is pretty consistent with anything when you're coding and doing bioinformatics or informatics in general. As long as you understand something exists and that it can be a problem, you can always fix it. So let's say you're navigating something on Hive and it says permission denied. You now know that if you want to switch the permissions, there's a command that does that. And all you need to do is look up whatever number codes you need for it. So that in itself is a skill that's helpful. Just knowing that it exists, knowing the tool is there, and knowing what you need to do is important. So I think that's all we have for today. It's the permissions and navigation. But one thing I do want to stress is I think last time people were having some trouble with GitHub. Um, we'll I'll touch on that next time because we're going to dive a little more into GitHub stuff next time. So we'll explain that a little more. But I think for today, that's all we have. So does anybody have any questions? No? All right. More of the story, don't be mean and hide your data from people, but also don't make it vulnerable so that people can change it when they need to or want to.
I
All right.
think it scares me when you have like everybody's data in one place and somebody's not really used to all those commands. Like, I don't know. It scares me to like just unintentionally destroy somebody's thing.
That's why we learned about the linking. I think if Paula was here, I would have probably used her as an example, but I wanted to rename some files to be consistent FASTQ versus FQ.gz format. And I was like, I don't want to touch your actual files, so I'm just going to link them all here and mess with the links. And I was able to do it and show her that the original files did not change in any capacity. So it's like stuff like that that's really helpful. There's a lot of safeguards that you end up being able to put in place the more you understand it. All right. Well, thank you all for joining.
Thanks, Vicky.
Thank you, Vicky. Thank you so much.
Thank you.